Okay, we're going to start the next topic in mechanics. We have two more topics left, energy, work and power. And the last topic is momentum. We're going to start energy, work and power today. I know there are some questions left in the connected particles worksheet. Um, I'm sure I gave you a few questions for homework for you. What I thought was, did you have any questions from that worksheet? Any difficulties? Or I'm just going to assign the rest of the, I think I already did that. I assigned the rest of the questions in the worksheet for you to do for homework. The last question we were discussing was an interesting one. I don't know whether you remember. There was a power cut issue at my place, so we couldn't properly do it, but a lot of you worked through it on your own with a uh, little help from me, but most of you did it. Oh, Malit, you didn't get the answer. Malit says he still didn't get the answer. Okay. Can I know how many of you got that answer? Okay, let me take you to the, let me open that for you, okay? Give me a moment. Connect particles. Right. Okay, please. Wait. Okay, here it is. Who's saying please, please, please? Someone saying please, please, please. Malik is saying, oh, you too, Hatfi. Okay, so if I remember correct, I think Kavindi got it. And who else got that answer? Let me show you. Let me take you to that question. I think it was, which one? This one? Yeah, Umalia got it. Great, Umalia. The total distance traveled by by B particle. We called them A and B. A is going down, B is going up. The total distance traveled by B during the first 1 second, 1 minute, what is it? During the first second, this all happens within a second, okay? Just within that time, all this is happening. This goes and hits, and this goes up, and the string gets slack, and it moves under gravity and goes up, reaches the highest point, and come down a little bit. All that happens in within 1 second. So there are okay. Do you all agree that there are 3 separate sections that we have to work out? The distance that B travels when the string is taut until A hits the ground, that is 0.64. That's the first one. Second part, from the when the string becomes slack, from that point onwards, the distance that B travels up to the highest point under gravity, that little distance, that's the second part. You find that. Add to that a little bit more until 1 second completes. This will come down until 1 second completes. You have to find the distance it comes down. Find that and add to that. So you're adding 3 pieces, 3 distances, 0.64 plus another answer plus another answer. So from which point onwards you want me to do it? We found that, okay, so can you provide me some information, or else I have to, give me a moment, give me a moment, okay? Okay. The final answer is, Hati, when it goes slack upwards, I'm stuck there. Okay. So just for the others, I will tell you the final answer of that. Final answer is 0.776. Let me type it here for everyone to see. So if you have gotten that, that is the answer. Total distance. Oops, what am I typing? total. Something wrong. Total distance is equal to 0.776 meters. That's the answer. Okay. And I will also show you now. This is just for those of you who got it, or just to see how far you have gotten it. These are the three separate distances that gives you that answer. 0.64 plus 0.128. Is Kavindi here today? I think Kavindi got this too. Plus, and where's Nathan today? Is Nathan here? 0.008. Okay. Kavindi got it, no? Yeah. Those are the three pieces. Okay. Okay, so here's the first piece. Let me show you then. What do I need? What information do I need? Yeah, exactly my question. Where is Nathan? Can someone, because my phone is occupied here with IV cam. Can someone drop a message in the group to see where Nathan is? He usually lets me know if he has to miss a class. Till you do that, let me copy down the information. Show that the accident particle to. First part, okay. First part is when the string is taut, when the string is TA, taut is T, I always, where's taut spellings? TA? Taut.
UT.
T-A-U-T? T-A-U-T.
Yeah.
Thank you. When the string is taut until A hits the ground. A hits the ground. I will show you the paper. We found the acceleration there is 2. We found it in part 1. Okay, so oh, it's stuck. Ayo, see, I always tell you I have 3 hands. Look at this. I have 3 hands. 1, 2, and the one that is writing. Oh, it's gone. He is saying he won't be able to attend the class. Oh. Kavindi, did he tell you why? Okay. Right. Okay. So here's the first part. This is from the point, if I draw a diagram for you for that, it's a pulley. From that point, here's the ground, up to, it's the ground, then up to that point, okay? So what is that distance that B, this is A, this is B. What is this distance traveled up? What is this distance? 0.64, 0.64. We know that, right? Is that clear to everyone? That is 0.64. Okay. Then the next part is, so this is part 1. Part 1. This is part 1. And then now A is hitting the floor here. So from that point onwards, the string will become slack, and A will be just there, just like a blob. It'll be just there. B would start moving up under gravity because it had a final velocity, some velocity it had. With that, it'll start moving upwards, but there is no other force on it now, no tension. The string is slack. So it'll be moving under gravity. So the gravity is pulling it down. So it'll slow down, stop, and come back, right? So we are going to break that also into 2 because we don't know when your 1 second will be over. So you have to first find out by this time how much time has elapsed. So do we know that? I don't think we know that. We have to find it. Okay. When B is here, now B is here. how much time has passed. How can we find that? We can apply equations of motion to this part of the motion of B. Okay. So for that part of the motion, what do I know? I know that this is for B. I'm applying for B during this string is taut. Okay, okay, Hatvi is giving me the time, but I will just do it anyways. I don't know how many of you like might need it, so I will do it. For B, for this part of the motion, always remember equations of motion are applied for sections of motion that you need. Now, the section that I'm considering is from this point, I might as well just use the pointer. From this point to that point, it happens in the same diagram, okay, though I have drawn two diagrams. So this from this level to that level, for the motion of B, like going up to there, while the string is taut. So U is 0, A is 2, we found A in the first part. It's a positive acceleration. And S is 0.64. I can find the time. I can find the time. Okay, and that's what Nathan has given me. What do you use? V equal, what? S equals ut plus. By using S equals ut plus half at squared, so I will not do it. You find that time is 0.8 seconds. So 0.8 seconds has passed by. There is how much more left for us to find the distance that B travels? 0.2 seconds more to complete 1 second. Okay, so by this time 0.8 seconds has gone. Okay, another information we need to find here. Now we know that we are going to apply equations of motion for the next section of the motion. For that next section, now B will start a different acceleration from this point onwards, which is gravitational acceleration. So acceleration changes. In this first section, A is 2. In the next section, it's going to be minus 10, minus G. So for that section, the initial velocity is going to be the final velocity of this section. Okay, so let me find it because I can use this as an information for my next motion. So I need to find V as well here. I will put V question mark. That I can find by using V squared equals U squared plus 2AS. What do you get for V here? 1.6. So it ends its motion in that section with 1.6. That means it starts the next section with 1.6. So 1.6 is the initial velocity for the next section, 1.6 meters per second. Okay, now here's the second part, part 2. Part 2 means second part of the motion. Okay, what is this part? I will say when or while, I think while would be a better word, while the string is slack, while the string is slack until B reaches the highest point, until B reaches the highest point. You know, motion under gravity goes up and comes back down. So I'm calculating up to going up because I don't know whether, because I am, why do I split it like that up to there and then coming back? Because I have to keep track of the time. I'm counting time here. I have to keep adding distance until I complete 1 second. So I'm going to do up to there and see whether I have reached my 1 second by then. Okay. So if I draw a diagram for that, so first part would be, here's B. I will draw A as well. A has hit the floor. And then this is slack and B comes to the highest point. So I'm now trying to find this distance. Okay. You don't need to draw like A, but I'm just drawing to show that it is slack now. B is slack. This is B. Okay, so this is the distance I'm trying to find now. That's from where we stopped in the part 1 up to it reaches the highest point. So for that section, again for B, I'm applying equations of motion. Okay. What is initial speed? 1.6, I found it there. What is acceleration? -10. That is gravitational acceleration. It's decelerating. What is V? I know V is 0 because I'm taking up to the highest point. V. Let me first find the time, just to see whether would I have already completed 1 second? Have I gone past 1 second, or do I still have some more to go? So just to check that, let me find the time to reach that highest point. So V equals U plus AT. You apply and you find time. How much time does it take to reach that highest point? You need a lot of concentration, lot of focus and clarity in your mind to do this question. What's the time taken for B for the motion under gravity to reach the highest point? 0.16 seconds. Thank you, Kavindi. 0.16 seconds. Have you completed 1 second yet? Earlier 0.8 seconds, and now another 0.16 seconds. Not yet. How much time is elapsed so far? 0.8 plus. As my calculator. See, I need a calculator to add those two small little numbers. It is say 0.96. Thank you, Malet. So altogether 0.96 seconds is gone. I only have to find 0.04 more. Okay. So, okay. Now, after finding this, I know I have to add that distance. So let us find that displacement S. What can I use? S equals ut plus at squared plus half at squared. And find S. What's S there? 0.128. So did you get that? 0.128 meters. Let me, so that means this is 0.128. Oh, it is 128? Yeah. Kavidi, that's the next part. Okay. So earlier, 0.64. I'm sorry, I'm just waiting till this catches up with my movements. Okay, first part, it had gone 0.64 seconds during a time of 0.8 seconds. In the next part, it's moving 0.128 meters up during a time of 0.16 seconds. Still our one second has not completed. So that means I have to from that top point, it will now come down. I have to only calculate the time. Sorry, I have to only calculate the distance that it's going to travel within how much of time? Umalia, yes, Umalia, you're right. Within how much of time? How much time left now for me? 0.04 seconds. Very good, right? 0.04 seconds left. So here's my third part now, number 3. Part 3. Part 3. What's happening in part 3? Still the while the string is slack. All this is happening while the string is slack. While the string is slack. From the highest point, until 0.04 seconds passes. During that time, I want to find the distance. So I'm only considering that little section of the motion. See how we take only a piece of the motion? So if I draw that, so this is slack from that top point until, now it's coming down until this point. During what time? 0.04 seconds during that time. I want to find, oh, I did not see that coming. Okay. But I will complete this, okay? So if I write equations of motion again for B, U is 0, starting from the highest points, U is 0, A is applying upwards, A is minus 10, time I'm using as time as an information. I want to find the distance traveled during 0.04 seconds, and I want the distance. Okay, S equals ut plus half at squared would give you S equals how much? 0.008. This is 0.008. That's the last piece of the puzzle. And you add all these three. See what a beautiful question this is. Would have been lovely if you get this just as a problem to solve, not at the exam. Because at the exam, you're under pressure and your brains do not, I think, do not work at their best, at an exam, because you're under pressure. But I'm sure if you're relaxed, you can tackle this question. I'm very happy to hear that, Malit. I'm very happy. The best feeling that I get is when I find out that you see something, you get something, that bulb turns on. Yeah, I like that. Okay, so there are, I think, how many more questions in that 7, 8, 9, 10, right? All of that I will now leave for homework. I'm sure you might have to think a little, spend some time a little, struggle a little, and that is exactly what you have to go through to gain this experience, okay, and build up confidence that, to feel that you can do a question on your own. So please do 4 more questions you have, do it for homework. I think I already said that last week, to do them for homework. You had 2 weeks. I don't know how far you have done. So we will take this up maybe next week, to check whether you have gotten the answers for all the 4 questions. Okay, so I will give you 1 more week to complete that. So the rest of the 4 questions for homework. Let us begin the next topic: work, energy, and power. Okay.